Alright, so 5.1 antiderivatives and indefinite integration. First of all, let's start out with the definition of an antiderivative. So, an antiderivative, and this is the actual definition. It is a function f is an antiderivative of f. By the way, this is capital, this is non-capital. So this is capital. Function f is an antiderivative of f on an interval I when f, capital F, prime of x equals to f of x for all x in I. Antiderivative is a function f I when f prime of x equals to f of x for all x in I. This one's capitalized and this one's not capitalized.
So the derivative of an antiderivative would get you known function.
The derivative of an antiderivative, yes, if you want to think about it. I feel like that definition makes it a little bit more complicated, right? If you think about it. In other words, what this is trying to say is that you're undoing differentiation. If you want to put this into, remember how we had the position formula, the velocity, and then acceleration, it's like you're going back to obtain the position formula. That's all we're doing. Cool? Alright, representation of an antiderivative. Not necessarily, just kind of thinking differently. I always misspell antiderivative. I think that's how you spell it. Okay, you ready? This is going to be a long definition, so if you just kind of, if f is an antiderivative yes of f, it's hard to tell, sorry, I'll try to do something. There you go. If f is an antiderivative of f on an interval I, then g is an antiderivative of f on interval I. If and only if, do you guys remember that's how I abbreviate it? If and only if g is in the form gx equals to f of x plus c for all x on the interval I, where c is a constant. Alright, so write that down and I'll pretty much summarize in everyday language what this means. Okay? I know. Okay? Alright, let me explain to you what this means, because when I read it, again, it doesn't really make sense to me, and I have kind of like that math brain. Yes, sir?
Wait, so we're saying f is an antiderivative of f, and g is also an antiderivative of f.
In other words, what this definition is doing on the textbook is changing f to g so you don't get confused. It's the same thing. What I'm really more interested of is this right here. And this is what you need to be interested on. So if you want to kind of highlight that or underline that, basically what this is telling you is that when you differentiate, okay, remember how sometimes you have a constant, and when you differentiate, it goes away because the derivative of a constant is 0. Well, when you integrate, how would you know what that constant is? Do you see what I'm saying? There's no way for you to really know whether you had a 1, a 2, a 100. Agreed? So in other words, when you're going backwards, you're going to get a function plus c, where c is going to be some constant. Sometimes you're going to have enough information to figure out what the constant is. Sometimes you're not. So you're just going to have some constant there. Okay, so let me just show you mathematically what this means. Here's the instructions. Differentiate the following. F of x equals x squared plus 7. And I don't know, f of x equals x squared minus 3. So if I differentiate the first one, what's the derivative? 2x. And if I differentiate the second one, what's the derivative? 2x. Agreed? So even though these are completely different functions, their derivatives are exactly the same. Agreed? So then the question becomes, when you are going to anti-differentiate, you're not going to have this. They're going to give you this. And they're going to ask you to go back to this. So without you having, you don't really know whether you had a plus 7 on a minus 3 just given this information. Agreed? You will be able to get the x squared part of it, but that constant, without any other information, it's not really possible to find. Okay? So when you take the integration or the antiderivative of this, your answer should be in the form of x squared plus c, because you don't know what that constant is. Agreed? Do we all understand what this definition is saying now? Any questions on that? Okay, this right here, we're going to call it the differential equation. And differential equations are quite important. There's actually a whole course on differential equations. We're actually not going to get too in depth. Imagine that, since there's a course that goes over differential equations quite in depth. Okay. All right. So here's your introduction to integration. First of all, let me kind of share with you the notation that you're going to use. Most of you guys have seen this. This looks like an elongated S. And you're going to have some function dx. Okay. This is not something that you necessarily need to memorize, but here's how it looks. Okay. And let me break down to you what it means. This part right here, the f of x right here, is called the integrand. Integrand. This dx right here is necessary because it tells you what's the variable of integration. So that means we're integrating with respect to x in this case. Agreed? Okay. This right here is your actual answer. That's your antiderivative. And lastly, this right here is known as the constant of integration. We're actually starting now. Second semester, we actually moved into series. Really, that's what makes this course complicated. That's when it actually starts getting a little bit more difficult than it has been. What's up?
truly calculus 2, or
Yes.
just
In other words, we're going to be done with calculus 1, not by the end of the semester, probably a couple of weeks after we come back from winter break.
but so okay, so we're not like interchangeably going this
Back and forth, no.
Yeah.
We're actually going in order. Yeah, it'll be impossible, I'm going to be honest. Okay? Alright. These are the parts of integration. Okay? The way you read this statement, right here, the way you read it is as follows. Antiderivative of f with respect to x. That's how you read it. In other words, it says, this part right here says, the antiderivative of a function in terms of x, with respect to x. Okay? And obviously this would be your answer. Cool?
So is it not like a antiderivative, or is it just
This little s right here, the elongated s. And as we'll learn in a future lesson, I like to think about it as an s, because what we're doing is sums. A bunch of sums. That's the way I look at it. Okay, but this basically the moment you see that symbol right there, integration. Cool. All right. I need you to go grab a book so that you can have the rules next to you, because we're just gonna start just practicing integration. Okay. All right. These are differentiation rules that you learned last time, right? During the entire chapter, what was it, chapter 4? You know that the derivative of a constant is 0. The derivative of something times x is just that something, right? You learned the chain rule, the power rule, the derivative of sine is cosine, etc., etc. You remember all this? Okay. Well, we're going to take this and now we're going to integrate them. So in other words, go backwards. If you have the integral of 0, that's going to give you some constant. You don't know what that constant is, and that's exactly what we're talking about, right? Later I'm going to show you how you can find it if you have certain information, okay? If you have the antiderivative of some constant, it's going to be that constant x plus c. And I'll show you how this can make sense here in just a second. This is honestly the same thing, just bringing the k to the outside of the integral because it's just a constant. Honestly, what I'm more concerned about is this power rule. And even them, they kind of put this red mark here. This is the one that you're going to use the most today. There's other ways we can use integration, but it requires a lot more calculus skills, and we're not there yet. But this one is the one we're going to be mostly using today. And this one's you're just going to have to know them and memorize them. For example, remember how we said that the derivative of sine was cosine? Well, the antiderivative of cosine is sine plus c. There's always a constant because you don't know if there was a constant. Okay? The derivative of cosine was negative sine. Therefore, the antiderivative of sine is negative cosine plus some constant. Okay, notice how all of these always have some constant added to it. So you must remember to have a constant. If you don't, I'm going to have to take points off. Okay? It's just for you to get used to it. Because there could be a constant, and I'll explain to you why it makes a difference. Okay? Remember the derivative of tangent was secant square. So the antiderivative of secant square is tangent. Cool? So in other words, you're thinking backwards. It's not anything that should be relatively new. You just have to take your time and go like, okay, hold on, I'm going backwards this time. Okay? But mainly, honestly, we're going to focus on this power rule backwards today. Cool? Alright, so if you want to have those handy next to you, and we're just going to practice anti-differentiating. Okay? So, for example, let's try the first one. Let's say I give you the following. How would you read that? What does that say? Good. The antiderivative of 3x with respect to x. Okay? Alright. I'll do a few of this with you first, and then I'll let you try it. Okay. The thing I like to do so I don't ever forget I always write plus c at the end. Okay, like right away, there's going to be a constant. I don't know what that constant is, but there is a constant. I look at this and I see a power rule, but backwards. Okay, remember that the power rule, very, very quickly, remember if you had like x squared, this is just an example, you would take this, multiply to the front, so that gives you 2x, and then you would say 2 minus 1, so that will give you 2x. Agreed? So first you multiply, then you subtract it. We're going to go backwards. So here, you technically have a power of 1, right? Instead of subtracting, you're going to add 1. So what's 1 plus 1? 2. Okay? And remember how you would multiply? Well, instead of multiplying, you're going to divide. What's 3 divided by 2? Agreed? Okay. You can always check your work with this. I know that might have been a little overwhelming for you if this is the first time, but check this out. What's 2 times 3 halves? 3. 2 minus 1? Does that work? Can I check my work? Alright, so let's kind of summarize what happened here. You're going to go backwards, and this time you're going to add 1 to the power, take the coefficient and divide it by that new power. Okay, that's what the rule says here. So let me kind of show it to you. In other words, it said, it's kind of shiny there, add 1 to the power, and what they're doing is like they're simplifying, but in other words, it's taking this divided by n plus 1. Agreed? Okay. Let's try another one. Antiderivative of 1 over x to the third with respect to x. Okay, what did you guys suggest I do? Because this looks like a quotient rule, agreed? And you're like, uh-oh, quotient rules. There was nothing about a quotient rule there yet. So, what do you suggest I do so that I can avoid the quotient rule? Yes? Good. How about we rewrite this as the antiderivative of x to the negative 3 with respect to x? Is that the same thing? From here, we can apply what I just did on part A. So this is going to be equal to, there's going to be a constant, agree? Okay. What are you going to do here? So instead of being negative 3, it becomes negative 2, and then what are you going to do? Which in this case was divided by negative 2 becomes, agreed? On the AP exam, they're more than likely going to expect you to not have a negative exponent. So just rewrite it as what? Negative 1 over 2x squared plus c. Agreed? Can you check your work to make sure you got this correct? What's negative 2 times negative 1/2? Positive 1, negative 2 minus 1 is negative 3, giving you right back to that. Cool? Alright, part C. Antiderivative of the square root of x with respect to x. Alright, what should you do first? Yep, I would just rewrite this as x to the 1/2 with respect to x, right? What's the answer? X to the what? To the 3/2 plus c, right? But then what's going to happen? 1 divided by 3/2, which is the same thing as saying 2/3. Agreed? 3/2 times 2/3, they're reciprocals of each other. They're going to cancel out. So that's 1, x to the 1/2, right? Plus c. I don't see why they would have a problem with you leaving the answer like that. But if this is on the multiple choice and you don't see that, they're probably going to turn it into a root. Agreed? Which would be 2 square root of x to the 3rd over 3. Right? Either or, you should be fine identifying I don't think if this isn't a free response and they don't ask you, you'd be totally fine to stop right here. Okay? How do we feel about this? Power rule backwards.
It's just different.
Different? Okay, then you try this one. Antiderivative of 2 sine x dx and antiderivative of 3 over x with respect to x. So try those two and then check your answer screen just a second.
How do you think the proof is?
Alright, let's talk about this. Part D. What I would suggest you do, because you kind of have a product, right? You can actually rewrite this by bringing that 2 out as follows. Mathematically acceptable. Okay? Then all you have to ask yourself is, what's the antiderivative of cosine? Well, what is the antiderivative of cosine? Well, but I am finding the antiderivative, right, of cosine.
So it'd be x plus c.
It's negative sine.
No, you're trying to find something. You changed it.
Oh, I got ahead of myself.
Yeah.
I was like, wait, what? Hold on, I got ahead of myself, y'all. Sorry. Okay. What's the antiderivative of sine? I'm sorry. Negative cosine. Agreed? Okay. Plus c, but you still have that 2 on the outside. So in other words, you have that 2 right there. Yes, sir.
Would we find that 2 to c simple multiply?
It's a very good question. Yes, you would, but no, because it doesn't make a difference, because we don't know what the constant is. Okay, so in other words, your answer should be negative 2 cosine x plus c. Alright, because you don't know what that constant is, applying that 2 is just going to give you constant. You still don't know what the constant is. Okay, it will not make a difference. So in other words, you're just going to keep that 2 with this antiderivative part here, and the constant, again, there's no way for us to obtain that constant. Okay? Alright, questions on that one? Part E actually gets a little interesting. I would have actually rewrote this as antiderivative of 3 times 1 over x. And then even further, you can bring out the 3 and have 1 over x dx. Agreed? Maybe it's a lot easier to see it that way. Because the way I look at this, if you try to make this x to the negative 1 power, right? When you add 1, it goes away. And then what do? You're just going to get a constant. Agreed? You're going to be like, well, there's a constant here. But that's not possible because you had x on the denominator. Okay? And remember that when you take the derivative of a constant, it's what? 0. So that doesn't make sense. Agreed? Remember, you should always be able to check your work. So then I'm like, okay, wait a second. This looks similar to something I've done before. The derivative of what gives you 1 over x? Natural log of x. So in other words, this is equal to 3 natural log x plus c. This one's, I'm going to be honest, this one's a little tougher to see. It's just one that you're going to have memorized. You need to remember that the derivative of natural log of x is 1 over x. Therefore, the antiderivative of 1 over x is natural log of x. Okay? Questions? We're good? Alright, so let's keep practicing. I thought those were relatively easy. What's the antiderivative of d of x? Well, technically, don't we have a 1 right here? I mean, I don't have it written down, but there is, right? So wouldn't this technically mean that I have 1x to the 0 power? Agreed? And if I apply the power rule backwards, I am adding 1. So what's 0 plus 1? 1. 1 divided by 1 is 1. Agreed? And think about it. What's the derivative of x? 1. Cool? Alright. what's the antiderivative of x plus 2 dx? Alright, so now we have a polynomial. It's okay. It's the same way when we had a polynomial differentiated. Take it term by term. Okay? If you wanted to, you don't have to, but eventually, I'm going to show you what you're capable of doing. You should be able to break this down into the antiderivative of x dx plus the antiderivative of 2 dx. You can break that down into two different integrals, which would be this rule right here. You see how you have that plus that. They're broken down into two different ones. You don't really have to learning this, okay? And then you just kind of look at one by one. What's the antiderivative of x? Well, remember, add 1 and divide by that number. So 1/2. Plus, what's the antiderivative of 2? We'll take x to the 0 power, add 1, so that's that. 2 divided by 1 is 2 plus c. Right? You can just honestly just kind of, without having to do that step, I'll just take a step by step and go from here to there, there to there. You're actually doing the step, but you don't really need to write it down. Okay, you're kind of just doing that in your head. Okay, you try this one then. Find the antiderivative of 3x to the 4th power minus 5x squared plus x dx. Go for it. Doesn't really matter. We'll find out. I mean, it's not like one is more likely than the other one, honestly. I agree. Alright, if you're watching the video, check your answer. Here's what I got. Something different. Okay. Let's make this a little tougher. So, x plus 1 divided by the square root of x dx. Antiderivative of x plus 1 over root x with respect to x. Alright, any suggestions for this problem before we even get started? Okay, so then you rewrite this as x to the negative 1/2. I mean x to the 1/2, and then bring it to up top to be x to the negative 1/2 times x plus 1. Okay, we could do that, but with the rules that we know so far, you won't be able to anti-differentiate because you don't really know of a rule dealing with products, right? Okay, interesting. So you're saying that we can rewrite this as x over, agreed? Is that the same thing? Okay, by doing that, how does that help you? Well, remember that you have, when you have a same variable, different powers that are dividing, you subtract the powers, right? So this is technically saying x to the first over x to the 1/2. Agreed? Yes. So then this becomes what? If you go ahead and simplify that. X 1 minus 1/2 is 1/2, right? You guys with me? And let's go ahead and rewrite this for our advantage. Can I just bring it to the top to make it? You guys with me? Did I lose anyone with what I've done here? It was just an algebraic step. From here, I think you can handle it. Differentiate this thing. I mean, anti-differentiate this thing, I'm sorry. So, add 1, x to the 3/2, and divide by that, so it becomes 2 over 3. Agreed? Plus, add 1, that's x to the 1/2, and divided by that. 1 divided by 1/2 is 2 plus c. Okay, here's something that I've seen done in the past. So when integrating quotients, so we had a quotient to begin with, do not integrate the numerator and denominator separately. Okay, what I mean by that is I've seen students try to do this. Add 1 here and then divide by 2. So that will be 2x squared. And then x. And then right here 3/2, so 2/3 x. Do you see what I'm saying? They try to look at the numerator separately and the denominator separately and apply the rules that we've known. Don't ever try to do that. Okay? It doesn't work. Do not integrate numerator and denominator separately. If you're able to break it down into what we did here, then fantastic. If not, there's some other skills I'm going to show you later on in this chapter. Okay? Questions so far? Alright, so then you try this one. Antiderivative of sine over cosine square x dx. Alright, for this one, I went ahead and rewrote it as sine over cosine times cosine. That's the same thing, which breaks down into sine over cosine times 1 over cosine, which ultimately breaks down into the antiderivative of tangent x secant x dx. This is one of those rules that you need to know from differentiation. What trigonometric function has a derivative of tangent x secant x? That would be secant x, and because we're taking the antiderivative, plus some constant. Okay? Questions on that one? Alright, I'm just going to give you, I have 4 more problems I want you to try where it involves this kind of algebraic manipulations, and then we'll move on to a new topic. Okay, so I'll just go ahead and write them down. Antiderivative of 2 over root x dx. Antiderivative of x squared plus 1 squared. Antiderivative of x to the third plus 3 over x squared dx. And then finally the antiderivative of the third root of x times x minus 4 dx. Okay. Briefly, let me talk about this. I'm not going to actually do them for you yet. I want you to try them, but this is a quotient rule. If we were doing differentiation, right? This would be like the chain rule. Agreed? This would be another quotient, and this would be like a product rule. Agreed? Now, you're going to have to think of those backwards. Now, you don't have the necessary skills yet. I haven't shown you how you would undo the chain rule, how you would undo a product, how you would undo a quotient. What I've shown you is you're going to have to rewrite this so that you can apply the power rule. In other words, agreed? That's all we're doing. Rewrite this in a way that you can apply the power rule backwards. Okay? You don't have the skills to try to do them in any other manner yet. Okay? So first, rewrite all of this. If you're watching the video, go ahead and check your answers. You can pause the video so you can check my work. The only thing that I would have done here differently, but I got lazy, is just don't have a negative power there. That's pretty much it. I would change it to negative 3 over x. Okay. Other than that, anything else should be acceptable for the AP exam. Cool. With the skills that we have right now, honestly, it took some algebra to manipulate all this in a way so that we could just have a whole bunch of power rules, so that we could apply the power rule backwards. Hopefully, this one didn't give you too much trouble. I hope you understand that third root of x is the same thing as x to the 1/3. So x to the 1/3 times x gives you x to the 4/3, and x to the 1/3 times negative 4 gives you negative 4x to the 1/3. And from there you should be able to differentiate. Anti-differentiate by adding 1 to the exponents, giving you this. Cool. Any questions over those 4 problems before we move on to something else, guys? Are we good? All right. So let's go ahead and flip the page. And let's talk about this whole constant thing and how we can find that constant. All right. Since integrating always includes a constant, this means the antiderivative has many graphs. So let's talk about the graphs now, graphically what this looks like. What's that? Yes, it's in half. Okay, so if you want to put that, sure. But let me ask you something. If you go back to Algebra 2, when you talked about transformations, if you're adding or subtracting some value outside of parentheses, what is it doing? They're vertical translations. In other words, you're going to have a whole bunch of vertical translations. So here's what I mean. If you have the antiderivative of 3x squared minus 1 dx, okay? If you take that antiderivative, what would you get? What number? What would it be? So x to the third minus x plus c. Agreed? Okay, if I graph this, we have maybe x to the third minus x plus 1, or maybe you can have x minus x plus 2, or x to the third minus x plus, right? Do you guys agree? Or x to the third minus x plus 0, and then on that direction. Agreed? You guys with me? Those infinite number of possibilities. Well, graphically, here's what we know. So that I don't have to spend too much time, let's just graph one of this and then just translate it. Okay? So if I use this one right here, the one with the 0, let's say I plug in the point 0. 0 to the third is 0 minus 0, 0, so you have a point at 0. Agreed? I don't know, let's plug in the value of 1. 1 to the third is 1, minus 1 is 0, plus 0, okay, so 0, okay. If I plug in negative 1, negative 1 to the third is negative 1, minus a negative 1, that's plus, so that's another 0. Interesting. Now, what if I use some of those pre-calc skills? I have a polynomial with an odd degree. What's the end behavior? Positive odd. It's going to go like this, right? Now, if I actually graph this, this looks something like this, guys. It's going to do this. It's going to do that. It's going to do that. And it's going to look like that. Right? Something similar. Here's what's going to happen. What if I have a plus 1? What's it going to do? It's going to move everything up 1. So I'm going to do this one in green. So then you have something that looks like this. Right? And what if I have plus 2? Then you have the purple. and so on and so forth. So you could have something like this. Do you guys see what I'm saying? And this will continue. It looks like a very nice pattern, honestly. Let me kind of show you something on the book because I got lazy and theirs look amazing. Look at that. Looks like that. More exact. And this continues going on and on and on and on and on forever. Okay. They won't. Okay. Very good observation. And they have more, and actually let me introduce you what you're actually going to see them look like more than what I just have there. You're going to see them look like this. With dotted, they're going to be dotted instead of solid lines. Okay? Why would somebody do that? Because you don't know which one of those graphs you have. Okay? Alright, so let me explain to you what that means.
Are we going to be doing that?
Yes.
Wait.
Okay, they're going to be dotted, just know that, and they actually have a name. This is called a slope field. Okay? This right here is called a slope field, and it will continue forever and ever. Okay? I don't know about that. But here's what we know. First of all, the way you're gonna see them is more than likely dotted, and there's a reason for them. Okay? Let's see. Now that you know what a slope field is, let me show you how you can find the constant that we've been looking for. Okay? So let's pretend we still have this function, this f of x equals x to the third minus x plus c. Okay? That's what this graph is, right? What if it was told to you, and I know I didn't draw this to scale, but you have a point right there on your slope field. That's what the slope field is going to tell you. You're going to have this slope field. It's going to look all dotted like we had, but then you have a point there. What is that telling you? That's where your graph is going through. In other words, it's telling you f of 2 equals to 4. If I drew this to scale, okay? That's what it's giving you. How can you use that information to find out your answer? Well, f of 2 equals x to the third minus x plus c. It's telling you to do what? Plug in 2 and your result should be 4. Agreed? So then it's going to say 2 to the third minus 2 plus c equals to 4. You guys with me? 2 to the third is 8 minus 2 plus c equals 4. 8 minus 2 is 6. Therefore, c equals negative 2. And therefore, f of x equals x to the third minus x minus 2. Cool? Alright, because I'm terrible at drawing, and I don't want to draw a slope field, I'm going to be honest with you. I'm going to give you an example, another example. So let's say I give you that, okay, and that f of 0 equals to 3. I need you to find the following. But the exact equation with the constant, because I am giving you extra information. Cool? Go for it. You're more than welcome to try to draw a slope field. And by the way, if the exam asks you to draw a slope field, you would have to actually draw a slope. Why not? Alright, if you're watching this, pause the video and check my work and check your answer. Moving on. Alright, last problem is actually a word problem. Check this out. You've actually done this problem before, but now we're going to use integration. A ball is dropped. Actually, let's not drop, let's throw it up. Why not? How about we throw it up? A ball is thrown up with initial velocity of 64 feet per second from an initial height of 80 feet. Okay? Part A, the position function given the height. Giving the height as function of t. So in other words, I want this to say s of t equals to something. And that's going to give you the position of this. Alright. If I would give you this problem in pre-cal, there was a formula that you had to memorize and you could give me the answer right away. Does anyone remember what that formula is? You're on the right track. Do you guys remember this formula? It was s of t equals to negative 16 t squared plus v naught t, right? Where v naught is what? Plus h. Do you guys recall that formula? Sort of. If you knew that formula and you memorized it, I'm going to be honest, and you have this question on the AP exam, I would just go ahead and plug in what I know. What would the formula be? Negative 16t squared plus 64t plus 80. Agreed? That's if you know formula. However, what if the test says you must use calculus? Then you have to use calculus. Okay? You can't just go there. So if the test says use calculus to find the position function of blah 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 blah, then you have to use calculus. Okay? And here's how you would do it with calculus. Well, here's what we know. Okay? We know that the velocity is 64, and we know that the height is 80, and we're looking for the position. Agreed? So if you go back to derivatives, the first derivative gives you velocity, and the second gives you acceleration. So then could we say then that s of equals to 64 feet per second if you wanted to, right? Or yeah, it is per second. But specifically s of what? S prime of 0, right? Why 0? It's the initial velocity. Agreed? Alright, what else do we know? What does that 80 represent? The initial height. Doesn't that have to do with position? So could we say, since it's the initial, it should be s of 0, right? Because it's the initial, equals to 80. And even though this is not written in the problem, you actually know s double prime at any value, negative 32, because we're in Earth, right? Gravity. So the acceleration. Do you guys agree with this? Do you guys understand where all this information came from? This, do you understand why it's just t rather than 0? The acceleration is going to be the same at any given point. Alright? Are we okay with that? Okay. How can we obtain the velocity formula? So you would say that the velocity would be equal to the antiderivative of what? Agreed? Okay. So then, therefore, wouldn't you say that the velocity is equal to the antiderivative of negative 32 dt? Agreed? Because that's your acceleration. You guys with me? What's the antiderivative of negative 32? Negative 32 x plus c. I'm sorry, t. Good catch. You guys with me? Well, how can I figure out that constant? Because I'm going to need to take the antiderivative of this to get the position, right? But I need to know what that constant is. What can I do? It's going to equal to what? 64. Agreed? Are you guys following with what I'm doing? Right? Then that means that C is what? Right? So now you can say that S prime of t equals to negative 32t plus 64. Agreed? You guys with me? Now, that's the velocity function. But they asked me for the position. So how can I find the position? The position function is going to be the antiderivative of the velocity function. Agreed? Therefore, the position is going to be the antiderivative of negative 32t plus 64 dt. Which in our case is going to be what? What's the antiderivative of negative 32t? Negative 16t squared plus 64t plus c. Agreed? You guys with me? And then I need to figure out what that c value is. Well, we know that the position at time 0 is what? According to this problem, it is 80. So S of 0 will be negative 16 0 squared plus 64 times 0 plus c equals to 80. Therefore, c is 80. Agreed? And therefore, S of t would be given by the equation of negative 16t squared plus 64t plus 80. Is that the same function we got earlier if you knew the actual formula? And that's actually where the formula came from. For those of you that were wondering last year, like where did that formula come from? From the calculus of it. Okay, so if the question, notice how this question didn't say anything about using calculus. If you knew the formula, you could have avoided all this work. But if the test tells you to use calculus, then you must use all these steps to find the answer. Okay? They do. It's a calculus test, so more than likely. I'm going to be honest. If they're going to ask you something else about that question involving calculus, they might just not include it. But if that's the question, then they're probably going to ask you to use calculus. And then we're done about the same question. Okay, so we're still on the same question. When does the ball hit the ground? And that's not calculus, that's just math. That's just algebra, I'm going to be honest. Find out when the ball hits the ground, and that's all I got for you. The homework is already on the calendar. If you're watching the video, I'll show you the answer here in just a second. Set it equal to 0, solve, and you're going to get two answers. One of them obviously doesn't make sense. It's negative time. You can't go backwards, right? So the only solution that makes sense here is that after 5 seconds, the ball will hit the ground. Cool? Alright, that's all I got for you. Next time, we're going to talk about Riemann sums. I'm draining a little bit. I don't really like Riemann sums, but we'll talk about Riemann sums next time.